Happy birthday to you. Happy birthday to you. Happy birthday, dear Spencer.
Brittany.
Happy birthday to you. All right, beautiful, beautiful. At the end, after I say that, then we'll hear the beginning so you can hear yourself singing. I think that one worked very well. All right, let's look at what we have. We have a little bit to look at here. Determinants. Square matrices have determinants, and the determinant is a number that can be used in different formulas. We'll use it next time for something else than today. So if I have this 2 by 2, we know A sub 11, row 1, column 1, stuff like that. We get the determinant, and you learned this in Algebra 2, you multiply these two together, right there. Minus, and we always subtract, and then we multiply these two together. So that math operation gives you one number called the determinant. And the notation are these two vertical bars. It kind of looks like absolute value. We use vertical bars in many different things in math. So this shows that we are trying to find the determinant of that matrix. So very simply, if I want to find the determinant of this matrix, we will go 5 times negative 3, and then we will subtract 2 times 3. What's 5 times negative 3?
Negative 15.
Minus 6.
Negative 21.
Negative 21. There's the determinant. Simple. So that's a 2 by 2 matrix. What about a 3 by 3 matrix?
Same thing.
Not the same thing. Unfortunately. You can't just multiply down that diagonal and subtract coming up because you miss some stuff. So in order to learn how to do that, we learn about things called minors and cofactors. What a minor is you can take any row and any column. I'm going to take this bottom row and cross it off, and then I'm going to take this last column and cross it off, and notice the values that are left right here. 2, negative 1. Uh-oh. I crossed off the wrong row to match theirs. There we go. Now look at the numbers that are left. 2, negative 1, and 8, negative 7. This is a minor determinant. And so I then use the determinant formula, 2 times negative 7 minus 8 times negative 1, do the math, negative 6. So that is the minor determinant for row 2, column 3. So we're going to use some minor determinants. And we are going to use cofactors, which include minor determinants. Here's what a cofactor is. This thing is the minor determinant. M, I sub j, some row, some column. Right in front of it, you go negative 1 raised to the power of the sum of the row and column you were on. So up here, we were on row 2 and column 3. If you add 2 and 3 together, you get the number. If you add 2 and 3 together, you get the number 5. Negative 1 to the 5th happens to equal negative 1. That would be the number that went in front of it. So to get the cofactor that goes with this minor determinant, so we have that negative 1 times the minor determinant. What's negative 1 times negative 6? A positive 6. That would be the cofactor for that. So let's just try finding minors and cofactors. They want us to find minor sub 32, row 3, column 2. So if I crossed off row 3 and column 2 and did this is the minor 32 that we are doing, I have 4, negative 2, and 5, 4 that is left. So I can now do my formula. 4 times 4 is 16, minus 5 times negative 2 is a negative 10. What's 16 plus 10? 26. There's the minor sub 32. Cofactor sub 12. Cofactor sub 12. So if I want cofactor sub 12, that's row 1, column 2. So I'm going to have negative 1 raised to the, what's 1 plus 2? Third, times that minor, 5, 4, 3, negative 6. So that will equal, what's negative 1 to the third? Negative 1 times, then I'm going to do this determinant. 5 times negative 6 is negative 30. minus 3 times 4 is 12. So that's negative 1 times a negative 42, which is a positive 42. That's called the cofactor, sub 12. All right? Now, the reason we do cofactors, and the minor is just to learn how we can do a cofactor, because a minor is part of a cofactor. The reason we do cofactors is when we get larger than a 2 by 2 matrix, cofactors are the way to find determinants. So here is the formula to find a determinant. Any square matrix of order 3 or greater, 3 by 3, 4 by 4, 5 by 5, 42 by 42, all we are doing is taking any row or column and adding all the cofactors in that row or in that column. Any row or any column. You get the same number. You get the same answer. It's the same determinant no matter which row or which column you decide to do. So here's the example. If we are trying to find the determinant of this matrix up here, the determinant of the matrix, I say pick a row, pick a column. They decided to pick this row. So what we do to get the determinant is 4 times the first cofactor, 21, row 2, column 1, plus negative 2 times the next cofactor, row 2, column 2, plus 3 times the next cofactor, row 2, column 3. And there they've shown all the math down here, and there's the answer, negative 27. Let's try one of those. See if we can make one of those things work. Find this determinant, and the only way we can do it is expanding by cofactors, it's called. Now, you pick the row or the column. It doesn't matter.
Row 1.
Row 1?
Row 3.
Oh, what a better choice. Why is row 3 a better choice?
Because 1 plus 2 is 3 in row 3. It's little.
Oh, I thought you had come upon a profound understanding. Notice what we're doing. We're taking all these numbers here and we're multiplying them by the cofactor.
Get the most zeros.
Aha! Get the one with the most zeros. This one has a 0 in it. I'm going to lose one of the operations I have to do because there's a 0 right there. So let's write this out. I need to go 1 times the cofactor that goes with that row and column. So 1 from this number. And then the cofactor, negative 1 raised to the, what row and column is this?
Row 3, column 1.
Row 3, column 1. 3 plus 1 is 4. Raise it to the 4th. Times the determinant of the minor that is left. Negative 3, 1. Negative 3, negative 1. 1, negative 1. 1. 1, negative 1. Plus... Now I'm going to write the one with 0, even though when we multiply by 0, we won't have to do the math. Then we're doing this one. Plus 0 times negative 1 raised to the, what row and column is this that I just crossed off? Row 3, column 2. 3 plus 2 is 5. And the minor that goes with it, the minor determinant is 5, negative 1. 5, negative 1, negative 2, negative 1. Plus... And then I keep going across that row. We decided we were going to use this one. So I just keep going across the row. Now I'm over there to the 2. So I cross off the row and column. So I have 2 times negative 1 to the 6. It's row 3, column 3. 3 plus 3 is 6. Times its minor determinant. 5, negative 3. Negative 2, 1. Negative 2, 1. When I do all this math, it should be the determinant of that matrix. And 0 times anything is 0, so that's why we picked that row. We don't have to do that one.
Yay.
What's negative 1 to the 4th?
1.
1. What's 1 times 1? 1. So I'm going to write the 1. 1 times, I'm going to do the determinant. Negative 3 times negative 1 is 3. Minus 1 times negative 1 is negative 1. Minus the negative 1 plus 1. Plus 0, don't need to worry about that. Plus, let's come over here. What's negative 1 to the 6th?
1.
2 times 1?
2.
2 times the determinant. 5 times 1?
Minus 6.
Minus negative 2, negative 3 is a 6. Minus 6. Let's see. 3 plus 1 is 4. 1 times 4 is 4. 5 minus 6 is negative 1. 2 times negative 1? 4 minus 2. There is the determinant of that 3 by 3. Any row, any column, same answer. 2. Next topic. First topic was finding determinants. So now you can do it at 2 by 2, real easy. Or 3 by 3, 4 by 4 with that second method. If a matrix is in triangular form, now we've done triangular form where we put all the zeros over here in the bottom left corner. Same thing is true that we're going to talk about if they're up there. You can do it that way. Doesn't matter. If we are trying to find determinants and we have it in triangular form, then the determinant is simply the product of that diagonal. Right there, that's what that says. It's simply the product of the diagonal. So sometimes with larger matrices, it may be easier to put it in triangular form and multiply the diagonal together. Now, up here they just said, oh, so A is 120 because they put all those numbers. 2, -2, 2, -2, 6, 5, -5. All right. But when you get it in triangular form, sometimes you change the determinant value when you do your steps, your elementary row operations. So here are the rules. If you interchange any rows, it's going to change the sign. So you just need to keep track. If I put it in triangular form and I switch the rows, the sign of that determinant will switch. If you multiply a row by a constant, then that determinant gets multiplied by the constant. If you add a multiple of a row to another, this is the elimination step. It absolutely does nothing to the determinant. So you can ignore those operations. So all I really have to keep track of is if I switch any two rows, or if I multiply a row to get a 1. That's when we do it, like we multiply by 1/2. Either of those things, then it's going to affect my determinant. But down here, that doesn't. So let's try one of those. We're going to evaluate the determinant, but we're going to put it in triangular form to do it. So I can get all of these zeros real quick. Negative row 1 plus row 2. This one, -2 row 1 plus row 3. And to do that one, that's negative row 1 plus row 4. Now, this will go a little faster than you think. You might be thinking, oh, it's going to be forever. Well, actually, the 4 by 4 cofactor expansion would probably take longer than this one. So let's see what we get. Now, notice I'm putting these in determinant bars. Those are not brackets anymore because we're trying to find determinants, so we have these bars. So 2, 1, -1, 3. Oh, and one other thing about that triangular form. You notice we're not worried about ones. We're not trying to make those things ones. Okay? So we don't care. We're just trying to get the zeros. So let's see. -2 plus 2, 0. -1 and 2 is 1. 1 and 0 is 1. -3 and 1 is -2. Check my math. I need a -2. So -4 and 4 is 0. -2 and 5 is 3. 2 and 4 make 6. -6 and where am I? And -3 is -9. Is that where I was?
Yeah.
All right, last row. So it's just negative. -2 and 2 is 0. -1 and 2 is 1. 1 and 7 make 8. -3 and -3 make -6. Okay, now I want to make these zeros. Well, not too bad. -3 times this row, I just use right above it. Need a little more room. -3 times row 2 and add it to that row 3. And just a negative of row 2 and add it to row 4. That should make it happen. Remember to give myself a little more room. All right, first two I'm done. 2, 1, -1, 3. By the way, have I interchanged any rows? No. All I have done is eliminating is multiple of one row to another. So I haven't affected my determinant at all at this point. Oh, I need to do my math here now. What are we doing? -0. -3 and 3 is 0. -3 and 6, 3. 6 minus 9, -3. Negative of this row. So 0 and 0 is still 0. -1 and 1 is 0. -1 and 8 is 7. 2 and -6 is -4. Okay, now I need to make this 7 a 0. Well, I can't make that 7 a 0 unless this 3 is a 1. So I need to go 1/3 times this row. And as soon as all I am doing is making a 1, I need to keep track of that. Let's see what it does here. Are you okay? Do you have a question?
Keep going.
Okay. I'm copying the first two. 2, 1, -1, 3. I didn't know if you were going to jump out of your desk and attack me. 0, 1, 1, -2. So 1/3 of this one. 0, 0, 1, -1. 0, 0, 7, -4. Now I can get my 0 there by doing -7 of row 3 and add it to row 4. Actually wanted to write
Did you
that
have
there.
just done that with row 2? Or
Up here?
yeah.
No, if I would have used row 2 up here, then this one would have added to that 0 and made it a 1. So that's why we can't go back. We can only go right above it.
Okay.
Otherwise, we reintroduce numbers into it that we don't want. All right, so the first 3 I'm done. 2, 1, -1, 3, 0, 1, 1, -2, 0, 0, 1, -1, and, well, 0 and 0 is still 0. -7 plus 7 is 0. 7 minus 4 is 3. There I have it. I'm going to multiply these diagonals together. So 2 times 1 times 1 times 3 is what?
6.
Now that is 6. But there's a problem. Up here I multiplied by 1/3, which means I need to do the opposite. I need to multiply by 3, and that will change it back to the correct determinant. 18 is the determinant. I take it you guys have started this already and we're looking at it?
Yeah, a little bit.
Ah, well, good. That's okay. So here are the rules. We sometimes have 0 determinants, and if you see any of these things, you automatically know 0 is my answer. If any row or column just has zeros in it, your determinant will be 0. If any two rows or columns are identical, they just repeat themselves, row or column, it's going to be 0. Or if one row or column is a constant multiple of another one. Let me give you a simple example. 1, 2, 3, 4. Let's say that's one row. And you notice another row. 2, 4, 6, 8. That's just a multiple of that one. It's going to be 0. The determinant's going to be 0. And then some properties. If you have two matrices that you're multiplying together and you're supposed to find the determinant of that, you could get the determinant of each one individually and multiply those determinants together, and it gives you the same answer. That's what that is saying. And the last thing, the last property that is true, if you want to get a determinant of an inverse, you can just take 1 divided by the determinant of the original matrix, and it equals the determinant of the inverse matrix. I'm done. Your turn.
Yes.